All right, folks, in the last video, we went through screening procedures for one-way ANOVA for our data set, again, looking at differences in response to a standardized emotion prime across within a diverse group of participants. Went through screening procedures in the last video. Here we're going to work through omnibus tests, plotting means, and then effect sizes and confidence intervals for one-way ANOVA and Stata. So the handout that we'll be working with here is just going to be one-way ANOVA for Stata. Again, our data set, we have participant number, our racial ethnic groups, and then 0 to 8 ratings of valence, 0 to 8 ratings of arousal. Okay, so here we've gone through, this is the set that we were working on previously. When we were going through and screening, we see our grouping variable here, ratings for valence and arousal, and then this is just stuff that came up during our check of our basic statistical assumptions. So what we want to do, we basically found that everything's looking good. All of our data are present. Values all are within range. There's a couple quirks in terms of the distributions, but nothing that looks like it would prevent us from moving forward. Have kind of an unbalanced design that would be worth noting, but nothing that would suggest that we shouldn't move forward with our planned one-way analysis of variance. The one thing that we didn't check within the screening video was our homogeneity of variance assumption. And remember that in Stata, we can check homogeneity of variance for independent sample t-tests or our one-way ANOVAs with our robvar command here. So what we're going to say is we're going to tell Stata enter robvar for valence by our grouping variable, which is going to be ethnicity. And what this is going to do, if we run this is just going to give us our Levene's test. Okay, so our Levene's test for valence by ethnicity. This gives us our means, standard deviations, cell sizes here. So again, we see an unbalanced design, but our numbers all add up to what we were expecting. And here's going to be our Levene's test, the one that we're interested in. We see that it does not meet conventional criteria for statistical significance, suggesting that these data are fairly compatible with the assumption of equal population variances, at least based on the data that we've collected. So we wouldn't worry too much about violation of homogeneity variance assumption in our analysis of valence. So feeling pretty good about that. We want to go through and then do the same thing for arousal. So asking for Levene's test, robvar for arousal by ethnicity. We run this, same thing, all our numbers add up, right? So we've got the same number of people, we're not missing anybody, but this time we see that our p-value for our Levene's test meets criteria for statistical significance. We get a p-value of 0.0019, indicating that we may have concerns with unequal variances across our white non-Hispanic, our black non-Hispanic, and our heterogeneous other group here. Okay. Again, if we go through and we take a look, it looks like our black non-Hispanic group is demonstrating the greatest level of variability. Here, we would want to we would note that this is standard deviation. If we wanted to get our variance here, we could hit display, and I think if we just go copy that, I think hat, will that do it? Oops. Open here. I think that will do it. Yeah. So our variance, our largest variance here is about 4.5. Our smallest variance for our white non-Hispanic group, if I hit display there, paste that. So 1.5 to 5.5. So again, in terms of our variance, enough of a discrepancy here to suggest some possible concerns with violations of homogeneity of variance for ratings of emotional arousal. So we want to keep that tucked in the back of our head as we move forward. and make a note of that in our screening analyses. So valence looks good in terms of most of our assumptions and homogeneity of variance. Arousal, some concerns with differences in the variability across the respective populations. So we'll start by running our one-way analysis of variance for valence. Pretty straightforward in Stata. ANOVA, valence, and then your grouping variable, in this case ethnicity. Pretty straightforward. Go through and run that. Stata gives us our ANOVA table here. We see 99 observations. Our root, mean squared error. This is just the square root of our mean squared error here. Remember that this is just like our pooled variance estimate for the whole design. And so across ours, think about this as like a pooled variance estimate for across all of our groups. This is just going to be the square root of that. Okay, and our r squared is going to be equal to our eta squared. Okay, if we'll go through and calculate eta squared in a moment, but it gives you it right here. The r squared is just the same thing as your eta squared. We would say, remember that for these data, eta squared being a nice descriptive statistic of effect size, saying that our racial ethnic groups are accounting for about 4.3% of the total variability in our arousal ratings. This is adjusted r squared. It's just a downward correction. We don't have to worry about this too much, at least in terms of ANOVA stuff. But what we see when we go through and take a look at our main effect for ethnicity here, we're not seeing evidence of, or our data aren't meeting conventional benchmarks for statistical significance. We have a p-value here of 0.122. So based on this, we would say that these data look to be fairly compatible with the assumption of the null hypotheses of equal ratings of valence across each one of these different groups. And so as a consequence, we would say that these data are these data are inconclusive in terms of whether or not we're seeing differences in ratings of emotional valence, just general pleasantness across a diverse sample in terms of how sort of amusing or pleasant they're finding this film that we're showing people. Okay, so other thing we want to do then, we want to take a look at arousal. But remember that for arousal, we had a violation of homogeneity of variance. Okay, and then this is problematic. We want to make sure that we make an adjustment. Basically, what happens because our statistical assumption, our ANOVA model, our F test is assuming equal variances across each one of our groups. And if we violate that, then our F isn't distributed as an F with the appropriate degrees of freedom. And so we need to go through and run a corrected or robust test for that. In Stata, what we can do is we can run a W test. This is our Welch's test. This is the same thing. It's going to give us an SPSS. Now, the one thing to know is that W test is a user-defined command, so it's not loaded automatically up into Stata. But what you can do is you can go find it, W test, and run that. And what Stata will do if we scroll down is we can see there it is, W test right here. And if we go through and we click on that, you'll see here it's telling you W test. It's giving you the help file for this. If we click on that, we say, oh, this is telling what W test is, how we go through and use it, right? So what you would need to do is just click on install, then it'll download the package and you can use it. Nice feature of Stata. I've already got it downloaded here, so I'm just going to go through run W test for arousal, again, because we have evidence of violation of homogeneity of variance. And so we're going to look at our one-way ANOVA by ethnicity here. So run this, and here we get our Welch's test, and we see with 2 and 47.17 our adjusted degrees of freedom. This is our test statistic, and we do have a p-value here of 0.037. suggesting providing some evidence, perhaps, of the possibility of unequal ratings of emotional arousal across somewhere in our white non-Hispanic, our black non-Hispanic, or our other groups, right? Now remember, this is just our omnibus test. It's just saying that at least one of these population means may differ than another population mean. Our omnibus test doesn't tell us where that is exactly, but it's at least saying, okay, there's maybe something to look forward to or sort of check out further within the context of emotional arousal. Okay, so for valence, we just use our regular old ANOVA command because we didn't have violation of homogeneity variance. For arousal, we're going to use a robust test or a robust analysis given violations of homogeneity variance here. Okay. Now, one thing we might want to do is we're going to need to do follow-up tests to go through and tease apart where things are actually maybe differing here. But one thing that's nice about Stata is Stata will go through and give you the marginal means by individual group, and then it'll go through and graph these out in a margins plot. Now, when we're requesting margins, this margins command is going to be a powerful one. It's one we're going to use a lot. But it's a post-estimation command. So if I just hit margins right here, Stata won't know what I'm talking about. So I have to rerun my ANOVA for valence here. Okay, so I'm going to rerun my valence ANOVA, and then I'm going to ask it to provide margins for ethnicity, and then I'm going to say I don't want p-values because I don't really care if things are 0 here. So I'm going to run my margins. Okay. And this is going to give me my marginal mean. So I've got my, for one-way ANOVA, these are just going to be the same as our observed means, but I've got our means for each one of my groups. And then it's also going to give me confidence intervals. Now the confidence intervals we're getting here are going to be different than the confidence intervals that we may find. No, we didn't get confidence intervals for that. But what this is using to calculate our confidence intervals here is we're using, and just to be aware, that what Stata is using is the mean squared error. The mean squared error here for our, to calculate the standard error for this confidence interval. So note whenever you run marginal means that the confidence interval for these mean values is based on what we ran in our overall ANOVA model. So it's taking this error variance and using that to calculate standard error for our confidence intervals. Okay, so we've got our means, we've got our confidence intervals around each one of the means. These are all looking pretty much the same, but that makes sense given that we failed to reject the null hypothesis up here. Our test suggests that our data were fairly consistent with the null hypothesis of equal population means across each one of our groups, but we might want to go through and plot this out. And so then in Stata, if we just hit margins plot and run that, it'll go through and give us sort of our both our means for each one of our groups and our 95% confidence interval. Okay, you can see the low end of our confidence interval for other comes close to capturing this. There's quite a bit of overlap. Now, it looks like we do have an increase, but we've only got a pretty limited scaling here. So not much going on here, it looks like, in terms of emotional valence. Okay, but we did find an effect for, or what looks like an effect for emotional arousal, right? Our robust test, our Welch's test, gave us a p-value of 0.037. Suggesting that there might be something there. Now, I can't get marginal means from W-test, but again, this isn't just, we're just here running mean values. So what I'm going to do is I'm just going to request ANOVA for arousal. Even though I had violation of homogeneity variance, I'm going to ignore the test. I'm not worried about that. But what I need to do is I need to run this ANOVA in order to get my marginal means. So I'm going to run my ANOVA. I request margins for ethnicity, no p-values, and then a margins plot. Okay. So I run those, and so here is my ANOVA, and we'll see that for when we don't run the robust test that accounts for violations of homogeneity of variance, we see that we don't quite meet traditional benchmarks for statistical significance here. I don't know that the two tests are really telling us anything categorically different, but by convention, we would say that we would fail to reject here. But again, we didn't run this because we're interested in this test. We just ran it to get our marginal means. So we get our marginal means here, get our confidence intervals. We see our biggest discrepancy between our lowest ratings of arousal among our white non-Hispanic group, highest around for our other group. And then if we go through and we take a look at our marginal mean or our margins plot, we see things are looking pretty similar across these two groups, but then our other group is quite a bit higher. Okay, so this is just a nice way to go through and plot out and see what's going on. Take a look at our confidence intervals here, a little more flexibility than what we get with our running this in SPSS. Okay. So the last thing we might want to do then, and another benefit of Stata, is we can run our effect sizes and 95% confidence intervals directly from the test. So once again, estat, esize is going to give us our confidence intervals, but this is a post-estimation command. So what we need to do is we need to make sure that we rerun our original ANOVA model that we actually want to get our effect sizes from. So we're going to rerun our ANOVA for valence. Okay, then we rerun that, and so now those effects are loaded up, and so I can run just estat esize. After ANOVA, if I run estat esize, what it's going to do is it's going to calculate my eta squared value. Okay, here we just have one factor, so we get our eta squared for ethnicity is 0.0428, which again is the same as our R squared. So estat esize in terms of just eta squared didn't give us anything interesting in terms of the point estimate, but what it does do is it also gives us our 95% confidence interval around around our point estimate here. Now, these data are our effect size here, our eta squared, is suggesting that about 4.3% of the total variability in emotional valence is shared with racial ethnic group. But our lower limit, remember, because we can't have negative variance accounted for, so our lower limit here is going to be 0 or undefined. So our confidence interval around our effect size is going to run from 0 to 0.132. Okay. Nice thing about Stata again is it gives us this. We don't have to worry about going through and running with our indice calculator and sort of converting upper and lower limits of that. We can just get it right from Stata. Now, the one thing we might have concerns about is we know that eta squared is positively biased. It's a fine in terms of a descriptive statistic for these data, but it's going to be too big in terms of our population estimate for our effect. So what we can do instead is we can rerun estat esize, but this time we're going to specify omega. And if we do that, estat, there we go. Here and stuff. Okay. Run this. Oh, yikes. Estat esize. Okay, this is what happens. And there we go. All right. Estat esize omega. There we go. Okay. So I'll run this just for a quick comparison. So we do a little side by side. Okay. So our eta squared, say for these data, our racial ethnic group accounts for about 4.3% of the total variability in emotional valence. But remember, that's positively biased. And so if we run, if we want a better population estimate, say for the population, in the general population, how much shared variance would we expect between racial ethnic groups and ratings of emotional arousal, or emotional valence? Our population estimate about 2.3% of the total population variability in the hypothetical population of individuals viewing this film. About 2.3% 3% of the total variability in that population outcome would, or ratings of emotional valence, would be attributable to racial ethnic background. So again, it's not, there are smaller effect sizes to be had, but in these data with a limited sample size, it looks as though responses that we're getting are relatively are not inconsistent with our null hypotheses of equal mean ratings of valence across these different populations. So again, eta squared are a nice descriptive statistic, but if we're looking for population effects, probably want to look at omega squared. Now, Stata doesn't give us confidence intervals around omega squared because calculation is complicated, but if we wanted confidence intervals, we'd go through and take a look at eta squared, not omega squared. Okay, same thing. We can do that, run these for arousal. Again, wanting to rerun E size is a post-estimation command, so we need to run our original ANOVA model for arousal, have those results stored in the system, and then we can request our eta squared and our omega squared. Okay, so we run that. We see here's our again, our uncorrected test, but we really don't worry about that for this piece of it because we're not concerned about our inferential tests here. We just want to get an estimate of effect size. Again, our R squared value is the same thing, and our ANOVA table is the same for our eta squared value because they're identical. But here looks like racial ethnic group is accounting for, say, 5.6% of the total variability in emotional arousal within these data. And again, lower bound on of the 95% confidence interval for this is still going to be 0, but an upper bound of 0.15. Here, our better point estimate of the population effect, suggesting that in the hypothetical population of individuals who would be exposed to this amusement prime film, we would expect that differences in racial ethnic background to account for about 3.8% of the total population variability in ratings of emotional arousal based on the data that we've collected here. So again, we see downward correction for omega. Okay, so that walks us through our analyses here. Again, we had a write-up, summary write-up in our lecture side, so make sure that you take a look at that. But otherwise, that should give you a good idea of how to run through and run our one-way ANOVA for data that don't violate homogeneity variance, those that do, how to go through and get some plots, and our effect sizes, confidence intervals, and things. So again, good luck with stuff, and let me know if you run any questions. All right, thanks.